Hello, and welcome to Backer Breaks It Down. In this episode, we are going to find area of sectors and segments of a circle. Okay, you're probably wondering, like, how do you find the area of a segment? I know they should really have given it a different name, but it's not what you think. Okay, so imagine pizza. So a slice of pizza, we'd call that a sector. The segment of a circle is the region between the chord of a circle and the included arcs. So like think of the crust of the pizza as like being what the segment of a circle is. Okay. And then there's something called an annulus, which really looks like a donut. Okay. I don't think you're going to get a pizza in that shape, although that'd be kind of neat. Anywho, let's develop some equations, well, some formulas for finding the area of these. So for the area of the sector, we've got this little picture equation. And so if you look here, it says A over 360 and then what? Then what? And then you get the like sector, okay? So it kind of looks like they're multiplying by the area of the circle, right? So basically, if we go A, which is the degree measure of the arc there, or the measure of the central angle. So A over 360 times pi r squared, that's how we'll find the area of a sector. Okay, now if you look at a segment, right, they're starting with a sector, really. That's what this is. So that's the area of the sector. And clearly they're subtracting the area of the triangle. So we're going to start with the area of the sector, which is the degree measure over 360 times pi r squared. And then we're going to subtract the area of that triangle created by the central angle and the radii. So minus 1/2 the triangle's base times the triangle's height, and that'll give us the area of the segment. And then for the annulus, the little picture equation is suggesting that we want to find the area of the big circle that has the big R radius. And from that, we want to subtract the area of the little circle. And that'll give us the area of the annulus. So now let's apply these formulas, okay? So area of a sector, that's probably going to be the one that you use the most in your problems that you encounter. So we determined that the area of a sector can be found by taking theta over 360. Theta is like the measure of like the central angle that's making that sector. And we want to multiply by pi r squared, which is the entire area of the circle. Okay, but this is the one you'll probably use the most. I think we're even using it here. So it says the length of the radius is 10 inches. What is the area of the shaded region? Express your answers in terms of pi. So the shaded region is actually made up of a sector and a triangle. So we want to find the area of the sector. So that'd be like this part right here. And then we want to add it to the area of the triangle. So when it comes to the area of the sector, I need to know like, well, what's its degree measure? And so you're looking at 3/4 of the circle here. So we're talking a 270 degree, like central angle is making that sector. And then when it comes to our circle itself, remember the radius is 10 inches. So this is essentially what we want to do. We want to go the area of the sector plus the area of the triangle will get us the area of the shaded area. The area of the sector, 270 is 3/4 of the entire circle. So that's what that's representing. And then pi times 10 squared is the area of the circle. When it comes to the area of the triangle, since the radius is 10 and all radii are congruent, the base and height of the triangle are both 10. So 1/2 times 10 is the area of the triangle. So we end up with 75 pi plus 50, and that would be your answer in terms of pi. Like we could come up with an approximate answer by typing that into our calculator and getting like a decimal answer. But the answer in terms of pi is 75 pi plus 50 square inches. Okay, so let's check out another one. It says in circle O, diameter AB and radii OC and OD are drawn. The length of AB is 12, right? So AB, if you look at your circle, is your diameter. So since that's the diameter, that means the radius would be half of that. So the radius would be 6, and that's what we need for area, right? The measure of angle COD is 20 degrees. If arc AC is congruent to arc BD, find the area of the sector BOD, right? So ultimately, we want to find the area of this sector. So in order to do that, we have to be like, well, what's the measure of arc OB? Not OB, BD. We need to know the measure of arc BD. And we know it's congruent to arc AC, okay? Furthermore, arc AC, arc CD, and arc BD make up half of my circles. So altogether, they make 180 degrees, okay? So if I do some math, I can find like the measure of arc BD to be 80, because I go 180 minus 20, 20 is arc CD. I'm dividing it by 2 because both angles and arcs have the same measure there. And then I get 80. So then I'm able to just find the area of the sector. That's what I'm doing here. Going 80 over 360 times pi times 6 squared. And I got the area was 8 pi. So in our last problem, it says the measure, let's see, in the diagram of circle O, the area of the shaded sector AOC is 12 pi square inches. So they're giving us the area this time. Like we know this, okay? The length of OA is 6 inches. So we also know the radius. Find the measure of angle AOC, and that's theta. So as always, formula, substitution, solution. So I immediately substitute in like what I know, okay? So I know the actual area of the sector is 12 pi. I do not know the measure of angle AOC, so I'm leaving that as is. And then I have times pi times 6 squared. And now I'm just going to do my math. So it looks like the first thing that I did was I multiplied both sides by 360. So you can undo that division of 360 by multiplying both sides by it, and that's what I did first, okay? Then the idea is I need to get the measure of angle AOC all by itself. So I need to divide by 36 and I need to divide by pi, and that's what I'm doing here on both sides, right? So that will get rid of the 36 on the right-hand side. That'll get rid of the pi on the right-hand side. The measure of angle AOC is now ready to be calculated. Doing the calculations, we get 120 degrees for the measure of angle AOC. So area of a sector, that's the big one of this lesson, can be found by taking theta, which is the measure of the sector's central angle. So we go theta divided by 360 times pi r squared. And that's how Backer breaks it down.